Welcome, guys. So now let's start to do some other interesting mathematical induction exercise. So I prepared like a three middle one and several very difficult one. Okay, so this is the middle one. This is not very difficult, but I think this problem is famous. Okay, so prove that 1 over 2 plus 1 over 3 up to 1 divided by 2 to the n will greater or equal to n divided by 2. So you can use this to prove that harmonic series will blows up, right? Okay, so if n equals to 2, then n equals to 1, right? And 1 half is greater or equal to 1 half, right? Trivial. Okay, so let's suppose n equals to k is correct. So 1 over 1 divided by 2, 1 divided by 3, up to 1 divided by 2 to the k will greater or equal to k divided by 2, right? This is our assumption. So now let's say n equals to k plus 1, right? So we have this plus the second plus the rest. The rest will be 1 over 2 to the k plus 1 up to 1 divided by 2 to the k plus 1, right? Which will equal greater or equal to the first original list term I leave, but the rest, right? The rest can be greater or equal to, you pick the minimum. So minimum is that 2 to the k plus 1. And how many terms from here to here, right? So you have 2 to the k plus 1 minus 2 to the k term. Okay, so this term is basically easy to compute. It's 1 minus 1 divided by 2, right? So it's k divided by 2 plus a half. So I use induction step here. I replace this guy to be this. So I replace this term to be this. So easy to prove this. So this is k, just k plus 1 divided by 2, right? So now we prove this result because we start from suppose n equals to k, and then we are able to use the induction step to show the n equals to k plus 1k is still okay. Okay, so basically I think this is the first results. Okay, how about we say the second middle one, and we will leave the third. As the next videos. Okay, so now we want to prove that 1 times 1 factorial plus 2 times 2 factorial plus n up to n times n factorial will be n plus 1 factorial minus 1. Okay, so let's n equals to 1, then 1 times 1 factorial equals to 1 plus 1 factorial, which is 2, right? 2 minus 1 is 1, so they are the same. How about n equals to k? Suppose n equals to k is correct. So 1 times 1 factorial plus 2 times 2 factorial plus up to k times k factorial will be k plus 1 factorial minus 2. Okay, so the rest is easy, right? For n equals to k plus 1, we just use the original assumption and add the k plus 1 term, k plus 1 for this term, right? And obviously that if we take out k plus 1 factorial, we get 1 plus k plus 1. So we get k plus 2 minus 1, right? So and this term becomes k plus 2 factorial minus 1. So using the mathematical induction, we are easy to prove this. Okay, maybe I just go through this one because I think these three are also simple. Okay, so this one is also famous that you can use this to prove that this 1 over n squared will converge by using the mathematical induction. Okay, so we want to prove this. Okay, so n equals to 1, 1 greater or equal to 2 divided by n equals to 2 minus 1, right? So it's correct. Suppose n equals to k is correct, so 1 plus 1 divided by 2 factorial up to 1 divided by k factorial, 1 divided by 2 squared up to 1 divided by k squared is less or equal to 2 minus 1 over k. Now how about n equals to k plus 1, right? So we will add this term, and this term combine these two terms will give you these two terms. Okay, so now you want to show this is correct, right? So basically you want to show these two terms summation will less or equal to this. Okay, so and you just do the manipulation and check that whether it's true or not. So we times the minus 1 become this, and then we then times k plus 1 squared. So it become k plus 1 squared minus k greater or equal to k plus 1k. And then you combine these two, you get k squared plus k plus 1 greater or equal to k squared plus k. So 1 greater or equal to 0. That means this is trivial, right? So total combine these two, you get this. Okay, so we show these three, and I will see you guys in the next video. So in the next video, we will go to some other difficult mathematical induction problem.